All right, y'all, let's take a look here at semester exam quiz number 5. Okay, this is part 5 of our review series. And again, we're treating this like every test review that we've done in the entire class. Okay, we always try and make it to where the review questions and the test questions are very similar. So the idea is that if you can answer these questions, you should have no trouble with the test itself. All right, so question number 1 of our last review quiz: which of these is the measure of an exterior angle on a regular polygon? Now, we've talked about exterior angle of a regular pentagon, excuse me. Okay, so the first that actually is the first piece of information we need to know, okay? Pentagon has 5 sides. And if it's regular, that means all the sides and angles are the same. All sides congruent, all angles congruent also. Okay, those two pieces of information right there at the top going to be very important. Okay, 5 sides and all angles congruent are both going to be very important pieces of information, because look at this. Okay, on every single polygon, funny thing that works out with the way that angles are measured and the way that exterior angles work, the sum of exterior angles every single time, no matter what, the sum of exterior angles on a polygon is always 360 degrees. Every single time, no matter what, it always equals 360. And so if you're looking for a single exterior angle on a regular pentagon, okay, you know that all 5 of them are going to add up to 360. And on a regular pentagon, all of them are the same because all the sides and angles are congruent to each other. So what we can do is we can just take that 360 and divide it by the number of angles. That right there is equal to 72, and that's going to be our answer choice. Turns out you can do that for any polygon at all. If you're dealing with exterior angles, you can always just take 360 and divide it by however many sides and how many angles you have. That's where we got that formula 360 over n that's found in your notes. All right. Moving on to question number 2. Hopefully it'll get loaded up here pretty soon. Been having some trouble with the internet today, so you know how that goes. Question number 2 is asking us which of the following gives you the measure of angle 1. Now, what we have right here is a trapezoid. We can tell it's a trapezoid, it's not any other kind of quadrilateral, because these two sides, the one on the top and the one on the bottom, are parallel to each other, but these two sides are not. Okay, so it's not a parallelogram, because a parallelogram has both sets of sides being parallel to each other, but a trapezoid only has the one set of sides. Now, this is a special, particular kind of trapezoid. This is what we call an isosceles trapezoid. And we can tell that because both of these legs right here are the same length. Okay, an isosceles trapezoid, just like an isosceles triangle, has two sides that are the same length. Now, the thing about an isosceles trapezoid is this. Um, when you look at the angles that are attached to the same base, they are equal to each other. So I'm going to recreate this figure right here. When we look at this picture, and this one is 55 degrees, well, that means this angle down here is also 55 degrees. Okay, this angle over here must also be 55. Now, we also know that this is a quadrilateral. All of the angles inside of this shape are all going to add up to 360. Sum of interior angles is 360 on a quadrilateral. And so what we do is we're going to take these two angles that we already know, and we're going to look at the fact that these angles up here are congruent to each other. And we can figure this out, okay? So what we know is this: 55 plus 55, those two that we already know, plus this unknown one, plus this other unknown one, which is the same, equals 360. Okay, we're just using a little bit of common sense, making some connections between the sum of all the interiors and the ones that we already know, and the fact that these two are the same. Okay, what it means is that these two down here add up to 110 degrees. Then that means these two up here, these two angles up here, must add up to 250. And if we're evenly splitting it between that one and that one, each one is going to be 125 degrees. Each one's going to be 125. So when it's asking about angle 1 in this picture, that'd be 125. Moving on to question number 3, if it'll ever load. Actually, you know what? As I mentioned before, we can use common sense and say that these two add up to 110, so these two must add up to 250. If you were setting it up, this is what the equation would look like. Okay, 110 plus 2x equals 360, and you end up with the same thing. You subtract and get 2x equals 250, and x equals 125. That's where all that comes from. All right, that's how we came to this conclusion that we had up in here. Now moving on to our next question, now that it's loaded. Which of the following statements is true about angle measures in this figure? Now, we have ourselves a kite. We have ourselves a kite. A kite is a very particular kind of quadrilateral where we've got those diagonals. Remember, the diagonals are what connects corner to corner. And we've got this side and that side congruent, this side and that side congruent. And those right there, those lines cutting across the middle of it are the diagonals. So it tells us that this angle up here is 44 degrees. This angle down here is 31 degrees. And it's asking us which is true about the angle measures in the figure below. Which is true about the angle measures? Now, here's what we know. Okay, we know quite a few things about kites. One of the first things we can recognize that's not in this picture is that right in the middle of this, these are all right angles. Okay, the two diagonals on a kite are perpendicular to each other. So what if we are looking at this as a set of triangles? What I see right here, what I'm outlining in blue, would be a right triangle, would it not? That would be a right triangle. And so we've got one corner that's 90 degrees, one corner that's 44 degrees. If the sum of every triangle is always 360, that means this one right here must be 46 degrees. And when I look at answer choice number 1, measure of angle 1 is 44. Well, that's not going to work, is it? That one's not going to fly. Up next, our answer choice asks us, is it possible that angle 4 and angle 5 are congruent? Well, again, we know this one is 90 degrees, and we know that this angle down here is 31. Well, that tells us angle 5 is also 31 degrees. Okay, the diagonals on a kite bisect those angles. Okay, this longer diagonal right here splits both of these angles in half. And so if that one is 31, this one must also be 31. Now, how would it be possible for on this triangle, I'm going to outline this triangle in green. On this triangle in green, I submit to you that it would not be possible to have angle measures of 90 and 31 and another 31 because that does not add up to 180. So this answer choice right here, angle 4 and angle 5 being congruent, that one doesn't track. However, this one right here, measure of angle 5 being 31, that one absolutely works. Okay, the reason that works is because we know these angles are bisected. Okay, one of the other things we learned about kites is that this distance right here is the same as that one right there. Okay, uh, these two pieces of our shorter diagonal are the same length, and so that means that indicates to us that this right here is an angle bisector. And so that means this one is 31, that one's also 31. All right, that's how we get to this answer choice right here. Interesting little things, kites. Funny how they work like that. Question number 4 is going to be a diagram, and I'm going to see if I can't recreate this diagram on here when it loads up. All right, we've got parallelogram, RSTW. It's been split in half by this line segment going across. We've got angle 1 and angle 2. We've got 115 degrees. We've got 36 degrees right there. Now, it's asking us what are the measures of angle 1 and angle 2. Now, here's something we need to recognize. When you're looking at this triangle, or when you're looking at this parallelogram here, what we have is two congruent triangles. And the reason for that is because of stuff we know about parallelograms. On a parallelogram, we know that opposite sides are congruent to each other. So I put one congruence marker on the top and bottom. I'm going to put 2 on the left and 2 on the right sides right there. Okay? So we have two sides that are congruent. But when you look at this shape, y'all remember these diagrams from back in probably topic 3 or 4 when we looked at congruent triangles. This right here, when you have a line cutting through the middle of the shape, you had to recognize that was a third side that was congruent for both triangles. Okay? That's a third side that's congruent for both triangles. And that means these two triangles are congruent because of side congruence. Okay, we've got all three sides that are marked congruent, so therefore the whole triangle is congruent. Now here's the part that you got to watch out for. Okay, angle 1, it's going to be pretty obvious which corresponding part that goes with. Okay, it's pretty clear that angle 1 and angle S up here, this 115, are going to be the same. And it is going to be very tempting to immediately look and say that angle 2 is going to be 36 degrees. But that is not the case. Okay? Angle 2 is not going to be 36 degrees. The one that's 36 degrees is going to be this one down here. Okay, this angle down here on the bottom corner is the one that matches up here. Okay, the reason that works is because that's the corner. The reason we know that's the corresponding part is because that's the corner that's connected to this side that has one congruence marker. Okay, this side has one congruence marker. Those are the corresponding sides of these two triangles. TW and RS are the corresponding sides. So that means the corner at RTW and angle TRS are the ones that are the same. Okay? Angle 2, the one that's labeled on our picture, angle 2 is the one that corresponds with this missing one down here. We got to do a little bit of quick math because we already know that we've got 115 and 36. Well, if we take 180 and we subtract 115 and then we subtract 36, that should give us the total for that angle right there. Okay? This angle right here, 180 minus 15, or excuse me, minus 115 minus 36 gives us 29. 29 degrees is what goes down in there, and that's what goes in for angle number 2. Okay? This is not an easy thing to grasp because it really is tempting to say that angle 2 is automatically going to be 36. But you have to recognize the corresponding parts. Okay? The corresponding corner of this triangle is not this one that's right next to it. It's the one that's down here. The corresponding part for the angle that it's asking for is the one that's over here that's missing. All right, so you can't just automatically assume that the one next to it is going to be the same. You have to look for the corresponding parts of these triangles. This side goes with this side. The side on the left goes with this side on the right. All right, got to watch out for something like that. That is the end of this quiz, and that is the end of our reviews. Okay, remember that if you can understand and get a grasp on these questions, you should have no trouble at all when the test itself runs around or rolls around over here. Okay, so y'all have a good one. Y'all study up and take care, and do well on this test. All right, y'all take care.